Welcome back. In this video, I'm gonna discuss this worksheet entitled Scientific Notation, Addition and Subtraction. So how do we add and subtract numbers that are expressed in scientific notation? So let us take a look at this example here. So what if we have 36 exponent 3 plus 3 exponent 3? So actually the idea here is that if you are really lost, you are confused, you don't need to worry, because if you just know how to add numbers, the normal numbers, then you can also do this. So how? For example, let's just take a look. What does 36 exponent 3 mean? So it simply means 36 followed by 3 zeros, because we just moved decimal place 3 steps to the right. If you want to convert this back to without an exponent, so 1, 2, 3, so it's 36,000. Okay, 36 times 10 to the 3 is 36,000. 3 exponent 3 is also just 3,000. Okay, and if you know how to add, like you have 36,000 pesos and you get another 3,000 pesos perhaps from the social amelioration fund, and then that means you get 39,000, right? So not a big deal. So if you got 39,000, normally we want our final answer to be written in standard scientific notation. It will just be like this. So we just now move the decimal 1, 2, 3, 4 until we get what? One digit or one number to the left of it that is non-zero. So this is just equivalent to having 3.9 times 10 to the 4. Okay? Or the idea here is that if you don't want to do this, if you are already familiar with the rules, if they have the same exponent here, like 3 and 3, we can simply add the numbers here and then just copy the exponent using these rules. A exponent m plus b times 10 to the m. You just subtract these numbers here and then just copy the exponents. So in that case, since 36 and 3 both are times 10 to the 3, you just add them up, 36 and 3. So you'll have now 39 times 10 to the 3. Okay? And with that, this can just be what? If you want to express this in standard scientific notation, the decimal is here. Since we want a number to be between 1 and 9, meaning we need to move this one step, because this is 39. It now becomes 3.9. But something will also change in our numerator, in our exponent, because since we're moving this decimal here to the left, it means that we add 1 to our exponent. It will now be 10 to the 4. Okay, so no matter what method you prefer, as long as you understand what you're doing, it doesn't mean that this one is shorter. This is always the one that you will use. Now, the idea is you can use this approach or you can use this approach as long as you know what you're doing, okay? But it's better to know both. Now, example 2, 54 times 10 to the 3 plus 3 times 10 to the 2. Now, in this case, they don't have the same exponent, so we cannot just directly just have 54 plus 3, because what will happen here? A common mistake for students will be this: 54 plus 3 is 57, and then they add the exponent also, times 10 to the 5. Why not? But this is incorrect, right? And I think we should know as of now, we know why this is not correct. Because 54 times 10 to the 3, if written in conventional notation, it will just be what? 54, the number that we are used to, that's 54,000, right? 54,000. And 3 exponent 2 will just be 300. Okay? Followed by 2 zeros, 3 times 100. Now, if you add them up, it's very clear now that when we add things, we need to line them up where the decimal is, here and here. So if you add them up, 0, 0, 3, 4, 5, it is clear that we should get 54,300. And if you write this in standard scientific notation, decimal is here, 1, 2, 3, 4. It's supposed to be 5.43 times 10 to the 4. Okay, not 57 times 10 to the 5. So this is like if we convert everything to conventional method, but sometimes this has limitation. What if there are so many, the exponent is big or the exponent is very small? then you will be writing too many zeros, and we don't want to do that. We're lazy a bit, and being lazy in calculation doesn't mean that it's bad. I mean, we just want to save time and we want to be efficient. So what shall we do? Well, what we can do is make this into the same exponent. Okay, there are two approaches. I mean, there are many approaches, but let me just show one. We can just step this down. I mean, we could just make this exponent down here into just 2. So how do we do that? Instead of 54, we can write it as 54. This is 54, the dot is here, I mean the decimal place is here, times 10. But if you move the decimal place to the right, instead of 54 you now have 540. That means you are subtracting you will subtract what? 1 to the exponent will now be times 10 to the 2. I hope that makes sense. If not, then go to this method. So what we do is we move decimal place to the right. Instead of 54, we move it one step to the right. But in doing that, since we're moving the decimal one step to the right, we subtract our exponent by 1. Why are we doing that? Because we want to make the exponent the same, in this case 2. Okay, so it will be 3 times 10 to the 2 also here at the bottom. We don't do anything at the bottom, so it will become now 540 plus 3, 543 times 10 to the 2. And writing this back into standard scientific notation, decimal is here. If we move this by 2 steps to the left, it means we add to our exponent 2. So it will now be 5.43 times 10 to the 4. Okay, so same answer supposed to be. It's not that we're using different methods and then we're getting different final answers. Supposed to be there will be just the same answer. Okay, some other method that could work here is that what if we just convert this one into exponent 3? So how can we do that? To make that into an exponent 3, we need to move the decimal here to the left, 0.3 now instead of 3. So now we are no longer in standard scientific notation because we want to do this because we want to force this one to have an exponent of 3. That is still allowed, of course, as long as you know what we're doing. Okay, so these are scientific notation, but just not in standard form because the number here is now no longer between 1 and 9. Now we can add them up since they now have both an exponent 3. So 54.3. Sorry, I don't write well. Anyway, I'll just rewrite 54.3 times 10 to the 3. Okay, and again, if you want to convert this to standard scientific notation, we need to move this one step to the left. So it will now be 5.43 times 10 to the 4. So all of these steps will give you the same answer. So choose wisely. Okay, I would like to try the second example here where we have this two being subtracted. Of course, subtraction is the same approach. So 63 times 10 to the negative 3, 2 times 10 to the 1. So if it's me, I will just make this everything into, I'll write this into all standard form. I mean, the conventional way of writing. So 10 to the negative 3 means I move the decimal place 2 steps towards the left. So decimal place is here. If I move 2 steps towards the left, I will be getting 360. So I'll be getting 0.63, right? 1, 2, 3. Okay, 63 is now written as 0.063, and 2 times 10 to the 1. It means I just what? I just move the decimal place 2 steps to the, 1 step to the right. So instead of 2, I'll have now 20. Okay, just be careful, of course, when you're adding things. You need to line up. If you're doing this manually without the calculator, it means 20, the decimal place is here. So how do you add them up? You need to line them up. I prefer, so meaning, what do you mean by line them up? I'll write it here. So line the decimal place 0.063, and then here the 20 is here. Okay, do not just put them together on one column. So if you add them up now, copy for the decimal as a marker, 0.63 here and 20 is here. Okay? So that's how you write it. And if you want to express this in standard scientific notation, so I just need to move this one step towards the left. So it will become now 2.0063 times 10 to the 1. Okay? So there are many ways of doing this. So the other possible way is that you convert this to exponent 1. That means you need to move this four steps to the left. Okay, if you want this to be exponent 1, you can just move this, because the exponent is -3, we need to move 4 steps to the left, so this will become what? 0.0063 times 10 to the 1. That's the first one, and then you add them up together. 0.00, oh sorry, we are subtracting, okay? I think I made a mistake. We are not adding. Oh, okay, so let me redo my work. So we are subtracting this. How do we subtract? 0.06320. Well, oh, I forgot. Oh, I should redo my work. So now let's have this. I'm going back to this one. 0.063, and then I have a 20 here, minus 20. So how do I subtract them out? Well, if you do subtraction, here the subtrahend is bigger, so we know that our final answer must be negative. So we can just shift them up. I mean, convert. I'll just have the 20 here, 20 point. The dot is here, and I'll have 0.063 here, and I'll just put zeros in this place. Anyway, we are allowed to do that. 20 is just the same as 20.000. And now I'm subtracting them. Just the bigger minus the smaller, but I know that the final answer must be negative. Okay, I'll just put negative at the end and my final answer. So how do we subtract this manually? I'm not really, I forgot how to do this because we used to use the calculator. Anyway, so this must be 10, and we need to borrow from here somewhere. So 10 here will become 9, will become 9, this will become 9. So what does this mean? Well, 20,000 is the same as 19,999 and plus 10. Okay, so we subtract now. 10 minus 3 is 7, 9 minus 6 is what? 3, 9 minus 0 is 9, copy that. So this is 9 and then this will be just 1. So 19.937. So this is wrong. Our final answer is supposed to be, we move the decimal place to the left, 1.9937 times 10 to the 1. Okay? But of course, we need to remember that we should put negative to this because we should put negative to that because we are subtracting a smaller number by a bigger number. Okay, so hopefully this is correct. Let me check. Yeah, so that's it. Made a lot of mistakes, but we learn from our mistakes. So this is the final answer for this. Okay, hope you learned something out of this session. Thank you.